Hi everyone, my name is TJ Richard. Welcome to my YouTube channel. Please remember to subscribe to the YouTube channel and click on the notification bell so that if I post a video, you'll be the first to receive it. Today our discussion on calculus and integration for the matter will be on integration of trigonometric functions. So before this video will end today, we will learn how to integrate all these three functions: sine, cos, tan, cot, sec, and cosec. However, if you did not watch my videos on integration by substitution and integration by partial fraction, I indulge you to go to YouTube and watch that video. This will be a very interesting discussion, so please watch the video till the end. So we start things off with one of them. Remember, we said if we differentiate sin x, remember the differentiations. When we differentiate sin x, we'll get cos s. So the reverse. When we integrate cos s, so the integral of cos s ds will be equal to sin s. Please take it. Remember it very well. The integral of cos s is sin x. Now remember also, when we differentiate cos s, we'll get negative sin x. Okay? So when we multiply both sides by negative, we'll get negative cos s will be equal to maybe the integral sin x. So remember that. So if I integrate sin s, I'll get negative cos s. So we say the integral of sin x ds is equal to negative cos s. Please take notice of it. It's very, very important. The integral of cos s is sin s, and the integral of sin s is negative cos s. It's the reverse of the differentiation. Remember differentiation, when we differentiate cos s, we'll get negative sin s. And when we differentiate sin s, we'll get cos s. It's the reverse. So the integral of cos s is sin s, and the integral of sin s is negative cos s. Please take notice of it. We'll be using it very, very often. The next thing is the integration of tan. The integration of tan. So, take this very important. The integral of cos s is sin s plus c, and the integral of sin s is negative cos s plus c. We'll be using that very often, as I told you. Now, we want to evaluate the integral of tan s ds. Remember, we said tan s is sin s over cos x ds. So we said that tan s is sin s over cos s. So I can rewrite this function as 1 over cos s sin s ds. I hope you get that. I just brought this here. If you multiply, you get this back again. So now I will let u to be equal to the denominator, the cos s. So my du over ds, remember, when we differentiate cos s to be minus sin s. Now I'll make ds, so my du will be equal to negative sin x ds. I need sin x ds, so I'll divide both sides by negative 1. So I'll say my negative u is equal to sin x ds. So we can say that the integration of this, that's the integral of 1 over cos s sin s ds will be equal to 1 over, what's our cos s? Our cos s is u. So 1 over u. What is our sin s ds? Our sin s ds is negative du. So we say times negative du. We can rewrite this as negative the integral of 1 over u du. Now we integrate 1 over u, we'll get ln u. So that will be negative ln u plus c. So now, what is our u? We replace. See, our u is cos. Our u is cos s. Remember, this is absolute value. So we can rewrite this as negative ln absolute value of cos x plus our constant. So We can conclude that the integral of tanx ds will be equal to negative ln absolute value of cos s plus c. I hope you get that. I hope you get that. Please keep it in mind. It's very, very important. The next one is the integration of chords. So we want to evaluate the integral of cot s ds. So let's see. Remember we said cot s. Cot is the inverse of tan. So we said this will be 1 over tan x ds. And tan is sin s over cos x. So when we reciprocate, this will be equal to cos x over sin s ds. This is what I'm talking about. If I have 1 over tan x, okay, it will be 1 over tan is sin x over cos s. Then I'll reciprocate this, so I'll get 1 times cos s over sin s. So that's the answer. Now, how do we integrate this? How do we integrate that? So now I will let u to be equal to the denominator here. So our u should be equal to sin x. Okay? Now differentiate this. Du over dx will be equal to cos x. Remember the differentiation of sin is cos. Now we'll make this the surface. So we'll get our du will be equal to cos x dx. Now we can rewrite this, then we substitute the necessary values. So we know u to be sin s and du to be cos s ds. We can rewrite this function as 1 over sin s cos s ds. So the integration of that, 1 over sin x, remember sin is u, so we have 1 over u. Then cos s ds is du. Now we integrate this. The integral of 1 over u is ln absolute value of u plus our constant. Pass u. U is sin x. So we say ln absolute value of sin x plus c. So we can say that the integral of cot x dx will be equal to ln absolute value of sin x plus c. I hope you get that. I hope you get that. The next one is the integration of sec. So, how do we integrate this? We evaluate the integral of sec s ds. Remember, sec is the inverse of cos. So, this we can rewrite this as 1 over cos s ds. So, what do? We can't just use any integration rule by substitution. No. Then what do? We need to multiply both the numerator and the denominator by sin. So we say this will be 1 times sin s, both by the numerator and the denominator by cos s. So 1 times cos s, then cos s times cos s dx. So what do we have? 1 times cos s will be cos s. Then cos s times cos s will be cos square s ds. I hope you get that. I hope you get that. Now look at it. Cos square s has a relationship with sine. Remember, cos square s plus sine square s is equal to 1. So we make cos square s the subject there, then we substitute. So we have this. I'll make cos square s the subject. So I say cos square s will be equal to 1 minus sine square s. So I can rewrite this. In place of cos square s, I'll put 1 minus sine square s. So I have integral of cos s over 1 minus sine square s ds. I hope you get that. What's the next thing? I will let u to be equal to my sin x. Because if I differentiate sin x, I'll get cos s. So I'll rewrite this as the integral 1 over 1 minus sine square s, then cos x ds. I hope it's the same thing. So what do? I'll let u to be equal to sin x. So what will I have? I'll differentiate now. My du over dx, remember, will be cos x. One differentiate sign will get cos. So we'll make du the subject. Du's will be equal to cos x ds. That's by cross multiplying. So I can substitute. So we say the integral of 1 over 1 minus sine square x cos x ds will be equal to, so 1 over 1 minus, what's our sin x? Our sin x is u. So we say 1 minus u square. Then cos x ds is du. So my du. Now I will resolve this into partial fraction, then integrate. So this is difference of two squares. So I can write this as the integral of 1 over 1 plus u, then 1 minus u du. So first I'll resolve this into partial fraction. So 1 over 1 plus u, 1 minus u will be equivalent to a over 1 plus u plus b over 1 minus u. Please check out my videos on integration by resolving to partial fraction. Now, how do we solve this? We have 1 over 1 plus u, then 1 minus u will be, the LCM here is 1 plus u, then 1 minus u. If this divides this, we'll be left with that. So we have a bracket 1 minus u plus b bracket. If this divides this, we'll be left with this. So 1 plus u. Now, since the denominators are the same, we equate the numerators. So 1 will be equal to a 1 minus u plus b 1 plus u. So we let u to be equal to 1. We substitute, any place you see u, will put 1. So 1 will be equal to a bracket 1 minus 1 plus b 1 plus 1. So 1 will be 1 minus 1 is 0 times a will be 0. 1 plus 1 is 2 times b will be 2b. So we say our b is equal to half. Now we substitute when u is equal to -1 and find our a. So we find b to be half. Now we let u to be equal to -1 now to find a. So 1 will be equal to a bracket 1 minus -1, then plus b bracket 1 plus -1. So 1 will be equal to 1 minus -1 will be 2. So a times 2. Then 1 plus -1 will be 0. So the whole of that will be 0. So we have our 2a to be equal to 1. A will be equal to half. So we substitute the value here. So we can say that 1 over 1 plus u, 1 minus u is equivalent to, what's our a? Our a is half. So 1 over 2, 1 plus u. Our b is also half, plus 1 over 2, 1 minus u. So the integral of this, the integral of 1 over 1 plus u, then 1 minus u du will be equal to the integral of 1 over 2, 1 plus u, then plus 1 over 2, 1 minus u du. So what we do? We integrate this by pulling. You see, half is common to them. We'll pull it out and integrate the results. So we're having this. We'll pull half out. So half out, the integral of 1 over 1 plus u, then plus 1 over 1 minus u du. So we have 1 half. Now when we integrate this, what do we get? We get ln absolute value of 1 plus u. Please check out my videos on integration by substitution. Now, when we integrate this, see, because of the minus here, we get negative ln absolute value of 1 minus u. Then plus our constant of integration, c. So, since this is what? This is a logarithm and it is subtractive, you can divide. So we say this is half ln absolute value of 1 plus u over 1 minus u, absolute value of 1 minus u, then plus our c. So this becomes the integral So the integral of sec s ds is equal to half ln absolute value of 1 plus u over 1 minus u plus c. However, u is not here, but we say u should be equal to something. So we remember we say u to be equal to, look at it, u to be equal to, so we wipe that from the beginning. We say u should be equal to sin s. So in place of u, we put sin s. So we can conclude that the integral of sec s ds is half ln absolute value of 1 plus, in place of u, sin x over 1 absolute value of 1 minus sin x, then plus our constant of integration. So this becomes the integral of sec s ds. The next one is cosec. How do we integrate cosec x? So we are going to integrate and we find the integral of cosec x ds. So remember, cosec is 1 over sin x ds. What do? I'll multiply both the numerator and the denominator by sine. So I'll get 1 times sin x over 1 over sin x, okay, over sin x times sin x. So what do I have? Okay, ds. So this will be equal to sin x over sin square s ds. So remember, sin square s plus cos square s is equal to 1. So we can make sin s have it. So sin square s is equal to 1 minus cos square s. So in place of sin square s, I'll put that. So I can say the integral of sin x over sin square s ds will be equal to the integral of sin x over 1 minus cos square s ds. So I'll just let u to be equal to the cos x, then I will do integration by substitution. So we have the integral of sin x over 1 minus cos square s ds. So we say let u, okay, let u to be equal to cos s. So we can differentiate. I circle this because I will substitute back. So my du over ds will be negative sin x. Remember that when we differentiate sin, we get when we differentiate cos, we get negative sin. So our du will be negative sin x, okay, ds. I need sin x ds, so I will divide both sides by negative 1. So negative du will be equal to sin x dx. So remember, we can rewrite this function, this, as the integral of 1 over 1 minus cos square s sin s ds. So that the integral of 1 over 1 minus cos square s sin s ds will be equal to the integral of 1 over 1 minus, what's our cos? Cos s. Cos s is u. So we have u squared. Then what's our sin s ds? See, sin s ds is negative du. So this can become negative the integral of 1 over 1 minus u squared du. I'll pull the negative out. So now I'll resolve this into partial fraction, then I'll integrate the results. So we have this. We can rewrite this as negative the integral of, this is difference of 2 squared. So 1 plus u, then 1 minus u du. Then we resolve this into partial fraction. So we'll pull it out. 1 over 1 minus 1 plus u, then 1 minus u should be equivalent to a over 1 plus u, then plus b over 1 minus u. So 1 over 1 plus u, then 1 minus u will be equivalent to, the denominator is 1 plus u, 1 minus u. So if this goes here to the left, so we get a bracket 1 minus u plus b bracket 1 plus u. Since the denominators are the same, we can equate the numerator. So 1 is equal to 1 minus u plus b bracket 1 plus u. So when our u is equal to 1, we substitute. We get a 1 minus 1 plus b 1 plus 1. The whole of this, 1 minus 1 is 0, so the whole of that will be 0. 1 plus 1 is 2, times b will be 2b. So 1 will be equal to 2b. So our b will be equal to half. So when we let u to be equal to negative 1, we substitute here. So we get 1 equal to a bracket 1 minus negative 1 plus b 1 plus negative 1. So we get 1 minus negative 1 will be 2 times a will be 2a. 1 plus negative 1 will be 0 times b will be 0. So our a is also half. So our a is half, our b is half. We substitute here to get the partial decomposition of this function. So we substitute the value of a and b here. So we have 1 over 1 plus u, 1 minus u is actually equivalent to, so we have 1 over 2, 1 plus u, plus 1 over 2, 1 minus u. So we can say that the integral of 1 over 1 plus u, 1 minus u du will be equal to the integral of 1 over 2, 1 plus u, plus 1 over 2, 1 minus u du. We can bring the half out. So we have half the integral, remember that our integration there is a negative here because we pull it out. So remember that there is negative here. So we have 1 over 1 plus u plus 1 over 1 minus u du. So when we integrate this 10 by 10. So the integral of this will be ln absolute value of 1 plus u. Because of the negative here, it will minus ln absolute value of 1 minus u, then plus our constant. So I have negative half. Since this is subtracting, we apply the law of logarithm. So we say ln 1 plus u, absolute value of 1 plus u, then absolute value of 1 minus u, then plus our constant. So we can just substitute. Remember we said u should equal to cos s. So in place of u, we just put cos s. So we can say that the integral of cosecx ds will be equal to negative half ln absolute value of absolute value of 1 plus cos x over absolute value of 1 minus cos s, because u is cos s. Look at it. Yes. Then plus our constant of integration. So this becomes the integral of cosecx. Please, we'll end it here today. The next time we meet again on integration, we'll learn how to integrate other trig identities. Please remember to subscribe to the YouTube channel. Until we meet again, bye-bye.